So, hello everyone. My name is Koji of Xcelux Design, and it's my great pleasure to be here again, making a presentation at the IP Showcase. So today, I'd like to introduce some of tips for the media over IP network design. I hope some of the topics help you to develop your ST2110 based facility. So this Friday shows today's agenda. So first of all, I'd like to introduce myself. My name is Koji Oyama, and as you know, there are millions of Koji in Japan. Very popular name. So recently, I changed my business name from Koji to Rosso. Yeah, Rosso. Call me Rosso. Rosso means red, color of red in Italy, and red is my lucky color and happy color in Asian area. So call me Rosso from now on. And I work at Xcelux Design, so my own company, and so I work as a technical consultant, and so support Japanese broadcasting stations and Japanese manufacturers. And this slide shows you today's goal of my presentation. So, and the first target audience is of course MoIP beginners. But there are two types of beginners, I think. So one is broadcast engineers who are not familiar with IP network design. Maybe they are familiar with SDI based network, but then they don't know the IP network so much. And other other target is IT network engineers who want to know the MoIP network. So they are familiar with the common IP-based network, but they don't know the broadcasting, technical term or something. So they don't know the grandmaster. What is grandmaster? What is a BB or maybe? So also other target is a project manager and leaders. I think they better to know about the MoIP design flow. So that they can estimate resource of the engineers and time of the design and verification. And so goal of my presentation today is that you can get a hint of running these technologies. I think 30 minutes is not enough to run everything. So hopefully you can get some keywords, and so you can after go back home you can Google some of it as a keyword. And this slide showed some objective of my project. So it's not some of my work, but so kind of the life work. So one of the life work is to spread out media over IP network design. And so our objective is to deploy enough MoIP network experts worldwide. So I don't know the situation in the United States, but in Japan, there now it's a lack of the such kind of the engineers so who knows both broadcasting technology and IP network design technologies. So recently, last year I introduced my group of the Slack, but the Slack is not familiar with the engineers. So I moved to the Slack to the Twitter. Twitter, you can just follow the account, and you can get some of the information about how to run the MoIP. So please follow this QR code. So I'd like to invite you to our community channel named MoIP Square, and it's open to public. And I will share template files of common network switches, and I will share issues to find solution. So, by using the kind of the social media, let's help each other. And in addition, some of the guys told me that such kind of it's. So we don't need to run about such kind of things because in near future, SDN controller will control the whole network. But this is my idea, and this is my thought. So if you not if you control by SDN controller, but guess when you guess you facing the issues. When you the situation, the network doesn't work. So if you don't know the fundamental network technology, you never analyze any issue. I think. I don't know. I think we need to run and we need to study such kind of things. And the next slide shows the abstract of the media over IP. So as you know, the input is multicast stream from the senders, and the output is multicast stream to the receivers. Very simple. But so you need to design and verify the media over IP network, media over IP network. And so stream is composed of the video, audio, metadata, and so that kind of data is packetized with the IP protocols. And then multicast for medias, and so we use media for the media transmission with multicast, and to control so we use unicast. And so currently we always use IPv4 multicast, not IPv6 at this moment. And UDP size specified in the SMPTE specification. And the receive media data. When you receive the media data, so you have to issue the IGMP, and based on the manner to send data when needed for the network path that requires transmission. And so currently we use architecture of this MoIP with IGMP version 3 and PIM SSM. Some of the equipment still use IGMP version 2, maybe the audio equipment or something. And so in that case, we have to use SSM mapping to connect V3 network and the V2 network. And so this is from the specification guideline of the JTNM TL 1001, this diagram is explain the abstract of the MoIP network. So maybe that you can see the touch point of the specification, SMPT, AMWA, and RFC, some such kind of thing. And then one of the important things for the network design. So we use for the multicast stream, we use IP address with first octet of the 232. 232 means for the PIM SSM. This is defined in RFC. So we use 232. You know the some of the multicast stream it is used with 239. This is a common multicast, but for the PMSSM, of the media over IP network design, we use 232 because some of the network switches in the MoIP network, some of the switch restrict to transmit multicast stream transmitting with 232, and refuse except for the 232. 239 stop multicast routing, but only some of the switch only transmit the routing with 232. So you should take care about it. And this slide shows the design flow. But it's also some example. And important thing is that we have to design physical network and logical network, because MIP, we use multiple stream inbound in one cable. So much different from the SDI, right? So first, we design a physical, list up the media and the control nodes and count the number of physical ports of equipment to be connected. This is a common workflow. Same as the SDI. But we also design a logical network. First, what we do is list all media and control sessions. Sessions means transport from sender to receiver. So not only the physical, but also the logical. Logically, we have to define the sessions and list all of the sessions. And next, we have to calculate the max bandwidth of each sessions. Because you know the one of the cable is up to the 10 gigabit, right? So but we can transmit multiple stream in one fiber cable. And so you can we can control the multiple streams, exceed bandwidth of the physical cable. so it's up to you. So we have to design, and we have to so control the number of the so stream inbound in the cable. This is one of the important thing. So much different with the SDA network. And then select so adequate network switches. And the next is other important thing. We have to assign IP addresses. IP address. I talked later. Some of the tips to assign the IP address. And then, so we have to structure design with the logical physical architecture and the isolation, etc. And we have to document, so make a documentation and configuration switches and review and so verification. Verification, I talked about so at the previous presentation in IVC last September. So if you are interested in the how to verify the MoIP, please watch the YouTube video. And this slide is so example of the IPM MoIP network. So media nodes, camera, video switcher, audio switcher, and the intercom, and so connected with L2, L3 network switches. And these are so for the media, and lower are so for the control network, control plane network. And Grandmaster spread out the PTP protocol to the node, media nodes. Very this is an example, and but one of the key so important thing is architecture is based on the and spine leaf architecture, spine and leaf switches. This is based on the ZTNM guideline. And you can configure the network switches. So one of the hard things for the network engineer. So the commands of the network switches so much different with the manufacturers. So if you use Cisco network switches, so you have to run the Cisco commands, and if you use Arista switches, you have to run about the Arista commands. And commands is so functionality of the command is slightly different. So you have to care about it. And so this is based. This slide is based on the my presentation last year. So this keyword is so essential for the MoIP network design. So you have to run about the VLAN, VRF, multicast routing with the PIM and the IGMP, and so routing protocol of the OSPF, and for the control lag, LSCP, VRRP. So if you don't know some of the keyword, please Google it. There are a bunch of the information online. We can Google it, and you can learn anytime you want. But so if you know this keyword, you can design a MoIP. So technology of the internet protocol is very huge. But so for the MoIP network design, we use some of them. So you know this keyword, you can design the MoIP network. This is slides last year. And this slides are based on the IBC presentation last September. And these slides introduced some of the tips for network design. Yeah, you can see the so you can watch YouTube video. So if you interested in the some of the keyword, please so watch the YouTube video. So next topic is I will introduce some of the tips for IP addressing. So as I told, so IP addressing is one of the most important important things. So you have to do at the for the MoIP network design. Nobody nobody do you have to do it. so 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 I will I'm going to introduce some of the tips. First one is a very so fundamental one. Use private IP address. This is one of the steps. But so as you know, so some of the broadcasting engineer, so they don't know such kind of things. So maybe if you are familiar with IP network. Oh, I know. This is a very fun but basic thing, but so this is first thing is a very basic. So you can use a private IP address, and and of course, so IP network design. Most of the IP network design, MoIP network design, is a closed network. So you can use any of the IP address, but if so for the future, you will connect with the internet. So I recommend you to use private IP address based on the internet specification. So this address class from the class A, class C. So for example, for media nodes, I assigned the 10.1 based address for the amber, and the 10.2 for the blue, and 10.3 for the control. So if you assign such a second octet is type of specifies the type of the network, amber, blue, control. You can see the IP address. We recognize which network. And the second is use limited to IP address. So use IP address efficiently. So as you know, IP addresses are limited. So maybe first thing is first you will design a very small network, but for the future you will connect other facility. But if you use a unique IP address, we can connect easily. But so if you assign the same address so for the facility A and the facility B, so you have to change the IP address with an NAT technology. So it makes more latency, and you have to choose more expensive network switches. So okay. So this slide shows tips for the IP addressing. Use mask slash 30. This is this means so if you connect with a camera and the network switch, physical logical networks are peer to peer. So you use IP address with 2. And for the IP addressing for so RFC specification. So if you use a /30 subnet, so we can get 4 addresses. But the first one is for network address, and the so last one is a broadcast address. So it's reserved. So we can use only 2 for /30 subnet. And so if you use /30, you can get 2 address. So we can assign. And the other thing is, do not assign /30 subnet address to packed. So if you you pack the address for the each equipment. If you use if you expand your specification, so for the equipment A, so for the from the one IP address to the multiple address, you can if you use such kind of a packed address, you assign so you assign the new address for the much different network addresses. So I recommend you the when you assign the IP address, reserve some IP addresses, assuming assuming in advance that the equipment A will need more than the IP address for one port. And I don't have enough time to explain the other issues, but I'm now facing on the such kind of issues. So for the network architecture, so as I said, so if you combine the IP infrastructure network, combine the two more than 2, and so each network is designed by the different engineer. So rule of the IP addressing is much different. So such cases if we have to consider how to integrate the 2 networks, which are designed with different thoughts and the idea. Some of the case, as I told, IP addresses are overlapped, so we have to match cast the net of something, more expensive network switches. And the second one is network switch selection. Nowadays we can choose Cisco, Arista, Mellanox, such kind of network switches for the data center, and also support PTP. But recently, lots of network switches are coming and released. So we have to choose. We can choose larger area, but as I said, commands it's much different. It's each manufacturing vendors. So we have to run about such a thing, and the command is a little bit command specification of the command is slightly different. It makes us sometimes it makes us trouble. And the last one is safety design. So we have to bandwidth management. So as I said, if you exceed the bandwidth network, some of the existing stream. So if you control, if you set the command to send the 1 to 2, and but existing, we can destroy some of the net streams easily. So we have to control the bandwidth, and we have to monitor the current streams. So other streams should never make it damage for the stream on the air. Okay, so I will, so I conclude my presentation. So now, so I'm faced on the greater shortage of MoIP network engineers. So we have to train the engineers. So this is so first priority. And the second one is so you know to train the engineer. So it takes some time to become an expert. So we consider how to train them. So so maybe they learn about the software engineer skill and as well as so how to run. Listen to the social media is one of the good thing to train and the good thing is to study and learn about something. So that's why I also started to the Twitter account, so MIP Square, to give them some of the tips or information to design MIP network. Okay, one of the more important thing is let's communicate. Let's communicate more among engineers. Okay, that is that's it. Yeah, thank you very much.